Good morning, evening, or afternoon, wherever you are in the world. My name is Burr Settles. I'm a research director at Duolingo, and it's my pleasure to offer a few remarks on machine learning for education from my perspective. And before we dive into it too deeply, let's talk a little bit about machine learning for education. There's a variety of different platforms or models that you might be using. You could be building a machine learning system that is used in a classroom with an instructor and several students. You might be building a machine learning as a service sort of API or platform upon which to build other educational systems. So maybe a generic intelligent tutoring engine, and you can build geography, math or language apps on top of it. Or you could be talking about something like Duolingo that bakes machine learning into an end user app experience. So there's no teacher or classroom or other layer of software. The AI is essentially the teacher for the students. So a lot of what I'll have to say is informed by that particular model, although I think some of the lessons learned apply to whatever kind of machine learning for education platform that you're building. And in case you're not familiar with Duolingo, we are a language learning app. It started as a Carnegie Mellon research project that spun out into a startup in 2012. I joined it in 2013. And today there are more than 300 million students across the globe learning any of the 90 plus courses that we teach, including Irish and Esperanto. We're expanding to more than 100 courses in the near future. We're working on Maori and Yiddish and several others. And all of the learning content is free. And how it works is that we have these game-like lessons grouped into skills by topic, and learners complete skills to unlock more rows. So this is one way that we sort of implement mastery learning. You have to finish a skill or a set of skills before you can move on in the curriculum. And users can choose to go back and review older material to level up and get more points or crowns. And the first time you do a particular skill, the item formats are much easier, and then as you level up, the formats themselves get more and more challenging, even though the core content, the vocabulary or the grammatical concepts we're trying to teach are the same. And then there are other gamified motivators and metrics and things like that. One feature of trying to build a B to C sort of machine learning educational app is the variety of types of users we get. So Bill Gates has been using Duolingo to learn French. The San Jose Earthquakes, their head coach is from Argentina, doesn't speak a lot of English. Most of the players don't speak a lot of Spanish, so they're using Duolingo to actually better learn how to communicate with one another. Here are some school children in Indonesia. And then occasionally you see news articles like this. Millions of Americans are using Duolingo to learn English. In fact, Miami English is the most popular language to learn, and in Sweden, Swedish is the most popular language to learn, in no small part due to the immigrant populations in those places who don't have access to more traditional, don't have easy access to more traditional language education. So we're helping to plug in the holes there. And that makes me really proud. There's mounting evidence on the efficacy. About 120 hours of Duolingo is roughly equivalent to 4 college semesters in French or Spanish, according to a recent study. And a lot of this success has to do, I believe, with the way that we use machine learning. First of all, I'll start off by saying I don't think machine learning is in the business of replacing great teachers. The best way to learn anything is probably with a one-on-one tutor who's a subject matter expert. But I also believe that until everybody in the world has access to a great teacher, I think AI and machine learning is the best way to scale this private tutor experience to everybody. And if you think about what a private tutor does, what a good one-on-one tutor does, I claim they have at least 3 important properties. One is that they know the material really well. 2 is that they have a way through their interactions with you of getting inside your head and understanding what you know, what you don't, what you struggle with, what you've probably forgotten, and how to engage you with the right material at the right time. And then they also know how to keep you engaged and excited about the material. And so we have machine learning projects focused on each of these 3 kind of missions or areas. And I don't have time, of course, to go over all of them, but I want to give you a taste and give one example of a project in each of these three areas. So starting with a good ML tutor that knows the material, we use machine learning to help aid in curriculum development. And one example of this is a few years ago, we realized that these short game-like lessons and vocabulary drilling can only get you so far. They can get you past the basics, but once you're an intermediate student, you need more experience with kind of discourse level content. So we started creating these podcasts in English, French, and Spanish, and Duolingo Stories is available in several of the languages that we teach. There's sort of these interactive radio play type things. And importantly, we needed to tailor the content of these to specific proficiency levels. So the content of these get into more intermediate and advanced territory, but we don't want to introduce things too soon. So what do I mean by proficiency level here? At Duolingo, we use the Common European Framework of Reference, which is a language kind of descriptive framework with 6 levels. The A1 level is basically survival skills in the language. Greetings, you can describe people physically, order food and drinks, things like that, but not really conversant, canned phrases. B2 is where you begin to understand complex and abstract texts, and you can argue viewpoints in the language. You might still make grammatical errors, have an accent, have to circumlocute a little bit, but you're functional and conversational in the language. And so what we did is we built an interactive editor for the content developers for podcasts and stories to use to be able to target a particular language level. So she is a dog, if you type that into the editor, that's super basic, it's A1, whereas the furlough scheme will be extended across the transatlantic region until the final days of March is a bit more sophisticated. It's kind of an upper intermediate level. And so the words are highlighted so that the developers know where they could go in and simplify and change the text to hit a target of A1 or A2 or B1. And then also if we paste in to be meta, the first paragraph of the Wikipedia article about CEFR, that's more academic and much more advanced. That's a C-level paragraph. Now importantly, we don't want this to work just for English. We want it to work for all languages. So for Spanish, if we paste in the first paragraph of the Wikipedia article, hopefully that also comes out as C. The challenge here is that English is a multi-billion-dollar a year industry, so there are lots of resources for CEFR alignment in English, but not these other languages. So how can we develop these curriculum development tools for French and Spanish, German, Italian, Portuguese, and some of the other popular languages on Duolingo? And the approach we took was a transfer learning approach where each dot here represents a word in English, like brother and apple are A1 level words, and as you move up the manifold, keen is a C level word. And this is a 2D projection of a multilingual neural network word embedding space as well as a language normalized frequency space. And now we've projected these words and represented them as points in a language agnostic vector space. So we could also then take Spanish words and project them into the exact same space, train an ordinal logistic regression on the labeled English data, and then make predictions and classifications in Spanish. So that's exactly what we did. This enabled developers of the Spanish Duolingo Stories and Podcasts to hit targets of A1 and A2, and then we ran some controlled A/B tests. So when we were first developing stories, there were no tools like this, and so there was no calibration. And once we had the tool and they'd gone back and revised, half of the users still continued to get the uncalibrated, unaligned stories, and half would get the CEFR aligned content using this tool. And after running this experiment, there was a 44% increase in people who had the option to use stories to come back and keep using the stories feature. And we also saw an almost 4% boost in Duolingo usage overall, driven basically just by the courses that had access to stories and these improved versions of stories. So switching gears a little bit, let's talk about a machine learning tutor that can get inside your head. So we use machine learning for knowledge modeling. And one fun example of this is once you finish a skill, once you've gone up to like level 5 in the skill, over time they'll crack, and that serves as a reminder for people to go back and review old material so that they don't forget it. And this is based on a statistical model of concepts in long-term memory. So for each exercise, we know all the different words and all the different concepts that we're trying to teach you with that particular exercise. They're tagged with it. And for each one of those tags, the model makes a prediction of the likelihood that you'll get that part of the exercise correct. And this model is personalized for each student and adapts over time as they learn. And the basis of it goes back almost 150 years to the spacing effect, which is the idea that people can learn better if their reviews, if their practices are spaced over long intervals instead of cramming. The forgetting curve is one implementation of this idea where you've got a time delta and a half-life in memory h. So let's say if I'm learning a new concept, it has a half-life of 1 in my brain. If delta is 0, if I just saw it or practiced it, it's almost certain that I'll be able to remember it correctly. After 1 day has passed, that's the half-life, so there's a 50-50 chance I will have forgotten, and after a week I'll almost certainly have forgotten. And there's a related idea called the lag effect, which is that people learn even better if the spacing between reviews gradually increases. Or to put it another way, this half-life sort of increases with more practice or more reviews. The implementation of this idea that existed in Duolingo before I started was a flashcard system called the Leitner system that literally harkens back to when you had physical flashcards. So there was a 1, 2, 4, 8 day box, and you start with all of your cards in the 1 day box and you practice them, and if you remember them correctly, they graduate to the 2 day box, and then you can wait 2 days before practicing them. Then if you still get it correct, it goes to the 4 day box. If you get that correct, it goes to the 8 day box. If you get it wrong, then it goes back to the 2 day box, so on and so forth. And I quickly realized that, this is, if you think of the boxes as these half-life measurements, then this is just 2 to the power of the number of times you've gotten it correct minus the number of times it's been incorrect. And we can generalize upon that. Instead of correct and incorrect as sort of features with coefficients of plus and minus 1, you could throw in arbitrary features and learn those coefficients from data, since you have a history of this user saw this concept with this lag time and they got it correct or incorrect. So to illustrate that a little bit, each X represents a student interacting with a word or a concept over their first 30 days of using Duolingo. What we're trying to predict here is the recall rate. So in a given exercise, what proportion of the chances they had to remember that word did they get correct? Also the lag time, how long has it been in days since they last saw this, at least within Duolingo? And then a feature vector of words that sort of summarize, of features that summarize their interaction with this in the past. And so what HalfLife Regression is doing is basically trying to learn this dynamic forgetting curve that goes through each of these training points as closely as possible. And in offline experiments, when we were experimenting with this idea of empirically driven forgetting curves, we had a data set of 13 million student learning traces, and HalfLife Regression was significantly better than the other spaced repetition heuristics like the Pimsleur schedule and the Leitner system, and also better than other machine learning baselines that we tried. Again, we put this into an operational A/B test. Half the users got the Leitner system, half got this new HalfLife regression model, and we saw significant gains in activity on lessons, on practice sessions, and overall activity. My background, of course, is in computational linguistics, not cognitive science. So once we published this, lots of people started sending me review articles like this one that applied hundreds of different functions to hundreds of data sets. HalfLife regression is an exponential forgetting function. There are other formats that are perhaps better. And so over the years, we've actually experimented with some of these other formulations. And the summary is sometimes in offline log data, they actually do make better predictions. But when we run these operational A/B tests, the results are either neutral or negative with respect to time on task or engagement. And this is, I think, an important point. When you're building a machine learning system for education, you have to pick an objective function. You've got to pick something to optimize. But it's really a proxy for the actual learning outcomes or the time on task or user engagement outcomes that you're concerned with. And sometimes there can be a mismatch. So just because your model does a lot better job at making predictions on the offline data, it's not necessarily going to translate into a better user experience. So yeah, are we just trying too hard in the machine learning land without actually trying to solve what the learner's problem is? Switching gears again to a good machine learning tutor keeps you engaged. This is kind of a fun project. So machine learning to encourage routine building. We send email reminders and mobile notifications to help users build a daily learning routine. But there are hundreds of different messages that we might send, of a little cute or encouraging messages that we might send. So how do we choose which one to send? We took a MultiArm Bandit approach to this. So it was a quick overview of MultiArm Bandits. Each of the arms represent the reminder templates that we might have to choose from. And then if we, for a particular user, pull a particular arm, send a particular template, there's a reward, which we define as, did they complete a session within 2 hours of us sending that particular notification? And then there's a policy, which tries to maximize the expected reward under those conditions. Now for Duolingo, there are a couple of additional nuances that are not typical to the MultiArm Bandit problem. One is that not every template is eligible. So some of the templates only apply in the morning, or they only apply on the weekends, or they only apply to users who have a streak of a certain length. So that would be analogous to a particular slot machine arm sort of just like vanishing after you pull it. Another interesting case is that the templates can go stale if they're overused. If this is a high-performing template, you don't want to send it every time because then it will start to lose its effect. So I don't have time to go into all of the details, but the way that we dealt with this is the reward function is proportional to a relative conversion rate between when the template is actually sent and when the template wasn't sent but was still eligible. And then we also have a novelty bonus, which is formulated similarly to the HalfLife regression. So basically, as soon as a template is sent, it's like now that arm has turned radioactive and there's a half-life to it, and you're penalized for continuing to pull it. But if it's been a long time since you pulled it, you get bonus points. And we retrain the system every night using the latest data. Here are some example templates that perform well or don't perform too well. And importantly, the same template will get localized to other languages, and they can perform differentially. So this first one, Hi, it's Duo, performs well overall, but it's particularly, for some reason, Portuguese speakers who are learning something on Duolingo find that one particularly effective. And again, we ran a controlled A/B test versus a random template selection baseline, and saw about a 0.5% improvement, which may seem small, but when we're talking about hundreds of millions of users, those translate into pretty big gains. And importantly, among new users in particular, we saw more than a 2% increase in uptake and engagement. And quickly, I want to close out with some other thoughts about engaging with the broader research community. Duolingo, we've tried to make it a policy to publish our work and also to publish our data because we're sitting on data that and dealing with problems that are not necessarily well known within the broader research community, the academic community, or other labs. And so this has helped us to enable new research. There was a Proceedings of the National Academy of Sciences paper building on the HalfLife regression, reanalyzing that data, and coming to some new conclusions. The best paper awarded at the Educational Data Mining Conference this year was a Bayesian item response theory model where they applied it to one of the Duolingo data sets that we've released with a shared task kind of Kaggle hackathon bake-off thing that we sponsored a few years ago. And it also helps with hiring. We've grown about 7-fold over the past 2 years in the research functions, and machine learning in particular. For every 1 slot we're trying to fill, we get about 1,000 applicants, and most of them cite our publications, the data sets, and the shared tasks that we've sponsored as a reason for applying. So hopefully you got something out of this. You can go to duolingo.ai to see all the papers and the data sets that we've released, and feel free to reach out if you have any questions. Thank you.